Welcome to our Hangar 2 Pavements Research Facility. I'm Tim Rushing, and I'm a research civil engineer in GSL here at ERDC, and I wanted to show you about what we do here in this facility and why it's important to the nation. So behind me, you see a big hole in the ground. Well, it doesn't look like much, but to a civil engineer, this hangar facility is basically a big sandbox full of very expensive toys. So what we literally do is dig holes like this one, and we fill them up. Well, it's a little more to it than that. So we fill them up with soil that's very special to us. One of the materials we like to use here in Vicksburg, Mississippi is, well, Vicksburg buckshot clay. So that's not very important to anybody except for us and maybe a few people that make neat pottery up in the Mississippi Delta areas. But it's basically like a modeling clay that's native to the Vicksburg area. Why do we want to fill this hole up with this modeling clay? Well, it stays its strength for a very long time. This clay likes water, it holds the water constant, the level of water in the soil the same, and so as we are doing any kind of experiment on it, it doesn't change. Well, that's very important to researchers, so we're probably the only people on the planet that ever buy it, but hey, we do, and we've used it since the 1940s to build sections on. So, this hole is going to be filled up with this modeling clay, and we're going to put something that we call an airfield matting system across the top of it. Basically, it's a portable airfield. It's something that we can use to create a surface. It's not like concrete or asphalt that maybe you're used to at a normal airport. This is for the military. When we want to go build an airfield on any flat spot on the face of the planet, we literally take construction equipment, we make a smooth area, maybe in a farm field, we put these metal planks across the surface, and then we start landing aircraft. So this is very critical to the force projection for our nation, and we've been using these systems since the 1940s. So this hole behind me, we're going to fill it with this modeling clay, put a mat over it, and we're going to put aircraft simulators on it. We're literally going to drive a simulation of an F-15 fighter jet back and forth and monitor how long it takes the mat to break or how long it takes the soil to deform under it. And we use that information to develop criteria so we can know if we go perform a military mission, how many passes of a real aircraft will it take before the system starts to fail. So generally that's what we do. We build highly controlled sections to evaluate the materials under simulated aircraft or other structure loads, and we test them to failure. So if you'll follow me, we'll move over here to the next hole you see in this facility, and I'll tell you a little bit about what we're going to do there. So here we are at another section that we're building here in Hangar 2 in our pavements facility. So this big hole is a little bit different than the other one, and it's long and narrow. This is actually going to be a road section. It's actually a road section that we're building for a private company. So here at ERDC, another thing that we do is we have a testing services agreement. So when the government has research facilities that really cannot be afforded by a private company, we can do work for them at just a cost reimbursable basis. So this is going to be a geogrid reinforced roadway section. What we're going to do is build a typical road section. We're going to reinforce different layers of that with different types of geogrid, and we're going to traffic this with simulated 18-wheeler loads. So instead of an F-15 or a fighter like we talked about in the first area, this is going to have truck traffic. So what does that do? Number one, it allows a company to evaluate their products, but we in the military can learn more about how we can better reinforce our pavements so we can reduce our thicknesses and our cost and perform more functioning pavements as we go to create expeditionary roadways in theater. So if you'll follow me, we'll walk down to the end of the hangar and I'll show you our HVSA or heavy vehicle simulator and tell you a lot about that piece of equipment when we get there. So now we're at the end of the hangar, and I wanted to show you the most amazing piece of equipment that we have related to pavements. In my opinion, the most important piece we have at ERDC. This is our heavy vehicle simulator. -A stands for Airfield version. What's so neat about this machine? Well, it's huge. When this machine was built, it was the largest one of its kind in the world. It's actually built in South Africa, and it was put on a seafaring barge, shipped across the ocean to New Orleans, and pulled all the way up the interstate system, probably much to the dismay of the people traveling on vacation that week, here to Vicksburg, Mississippi. This machine in total is 120 feet long, and the unique thing about it is it has this amazing load carriage here behind me. Right now, this load carriage has a set of dual tandem truck tires. So basically it's simulating an 18-wheeler, but it can be configured with anything. It was originally designed and used mostly for airfield loads. So This big system here can put 100,000 pounds of load down onto a paved surface and hold it there as it traffics back and forth across any item of interest, whether it's a road or a bridge section as it's on now. And we can basically put 20 years worth of design traffic on any transportation surface in a matter of basically like 1 to 2 months, depending on the number of passes to failure. So just like we talked about at the other end of the hangar, where we have matting systems and we're monitoring how many passes it takes to damage them or break them, that's what we do with this machine. But this machine is actually designed to test your standard pavements, concrete pavements, asphalt pavements, or even bridges, things that are designed to last a very long time under very high loads. We need to understand how they perform, but we need to do that in a condensed amount of time. So this heavy vehicle simulator lets us do that. So it literally drives itself back and forth. We can run this machine 23 hours a day without stopping. We bring it down for 1 hour for inspection and data collection, then we're up and running again. So this is the workhorse of our test equipment for transportation infrastructure assessments. This helps the Corps of Engineers design better bridges, as this one is behind us. This is a prototype bridge for the Army, looking at new line of communication bridges. So we're looking at the bridge deck itself and monitoring all of the structure underneath. But this thing has primarily been used since it was built in 1998 on airfield sections. And so we've used this to allow things like warm mix asphalt, so we can reduce the temperatures of our asphalt to be safer for the workers and better for the environment. Allow those to be used on our military airfields, to any other types of new materials that may be come out on the market. All right, well, thanks so much for following me through the tour of Hangar 2. Again, this is our pavements research facility, and what we do here is we build sections of airfields, but also roads and bridges to develop the criteria that is used to make better infrastructure for our military and our nation. And so thanks for following me around today. I hope you enjoyed what you got to see, and know that here at ERDC, we have all the resources needed to do the transportation research and make sure that we continue to be able to enable our force projection mission well into the future.